Hi everyone, really excited to be here and present on this topic today. I will focus on what we're doing on site and hopefully just start a conversation around this this specific area of carbon and embodied carbon, and kind of show you a little bit about what MACE is doing and what we're trying to do and what we're trying to achieve. And it's probably going to be a little bit of a call to action, as Will said, I've been talking about this for some time and I haven't quite cracked it yet. So I'm hoping there'll be people in this room that are interested in helping us out as well. So just for some context, for those who don't know, MACE is an international construction company and consultancy. We are predominantly based in, we come from the UK and very London focused, but we have offices and projects all over the world with kind of key hubs in different regions. And at the start of this year, partly as a result of the pandemic, where we sort of really had to step back and think about how we worked, we launched our redefined strategy, so our new business strategy, which actually put the pursuit of a sustainable world and supporting the built environment's response to the climate emergency at the start. So as a sustainability consultant, that was pretty exciting, and really demonstrated to us in our team. There's about 80 of us now. The businesses that we are being empowered to across the business to deliver on. And we have some key targets there. Again, really just a high level, just to show our commitment. So we're not just looking at our own corporate commitment, but we want to help our clients reduce their own carbon, which is why I'm also here today, to try to give you ways to help reduce carbon on your own projects. And then we think that the work that we do in this space also contributes in terms of what we call our value to society. So just a little high level introduction on kind of the MACE perspective on all this. I won't really spend much time on this. I think I don't know whether people are just dialing in for a few events or sitting in, but I'm hoping most people on the call are pretty familiar with the kind of the different life cycle stages, but just in case you aren't, really what I'll be focused on talking about today is the A5. So the materials that the carbon from materials, that extraction, transport, manufacture is kind of the topics that were being talked on in the talk just before, is kind of really what we call cradle to gate, and then you move into cradle to practical completion, and that's what I want to focus on today. But I think, as some of the others mentioned in that Q&A, really important to have that big picture view whenever you're talking about this stuff, and making sure that we're thinking about how the activities we have in one space impact the others as well. So just moving on, again, what kind of contributes to A5, and maybe why is it a bit of a challenge to measure it? You know, and have a sense of how much it contributes to an overall carbon footprint of a project at the moment. Really, our experience is probably the biggest contributor is our fuel use on site. So a lot of sites are still heavily reliant on diesel generators, on machinery and plant that will use some form of fuel. And that could be anything from a crane to an excavator to a platform, cherry picker and the likes. You then have your energy use, which can be quite significant. Again, we talk about sort of temporary power and temporary accommodations, but at MACE, we've got several projects that will have been on site for 3 to 5 years and upwards of that. So actually that temporary, that word temporary can be a little bit almost misleading at times, because you think maybe it's a small impact, but it can really add up. And you know, that means that we need to power everything that we're doing during construction, from our accommodation to, you know, the tools that we're using when we're building, lighting, security, so on and so forth. And then one that I think is still a challenge and not always very well captured is the water use. So it's more indirect carbon footprint, but any water that we do use on our construction projects will have an associated carbon footprint, and any waste that produce. And I've got that in bold and in green because I think that's also a really key one. So that is going back, sorry, just slightly to the time frame here, the reason I kind of put that in bold is because any waste that we produce not only has emissions associated with it because we have to dispose of that waste, but actually that is material that has had an A1 to A4 impact. You know, those emissions have happened because that material has been produced and brought to site, and then we're disposing of it. So it's a bit of a double whammy in terms of kind of carbon impact. And I think why it's really critical that we're thinking about that when we're looking at what influences and how we might go about reducing our A5 impact. So does it matter? I think so, definitely does. How much I've put to be confirmed, and I'll go into that kind of question a little bit more on the next slide. But really, I guess the reason I think this question gets asked is that, you know, the current guidance, whether it's the LETI Climate Emergency Design Guide or the iStruct tool, have ways of estimating the impacts, and they suggest that it's, you know, kind of between the 1% and 3%, which might make us think that, you know, it's given the challenges we have with the other elements and the other aspects of embodied carbon, maybe it's something we don't need to really worry about just yet. But for us as MACE, it definitely is. So from the contractor perspective, in 2019, it probably accounted for about a third of our overall corporate carbon emissions. We're a signatory of RE100, which means that any fuel that we use, any generators we use to power our sites, we have to account for, and is kind of factoring into us achieving that commitment that we've made or not. So definitely important to us as the contractor. But actually, and what I kind of want to touch on is, you know, I have a sense, whilst I might not quite have the scale yet, is I have a sense that that percentage is potentially currently underestimating the true impacts of construction activities on our whole life carbon assessments. So we've been doing, again, over the last couple of years, we've been doing in-house embodied carbon assessment. We use the one-click LCA tool, and in the models that we're doing there, the estimates are starting to come out a little bit higher, about 5 to 10%. Again, this will really vary on the project, but again, you know, what that shows is that it's still you know, it's still a smaller percentage, excuse me, compared to that of you know, of our materials, of our A1 to A3 and potential replacement of MEP. But some of the things that I think aren't being captured or aren't being captured entirely at the moment are the waste rates. So I think on the iStruct guide, it suggests a waste rate for plasterboard as an example of about 22%. That might be fine in terms of an average. Unfortunately, on some projects, we have the MACE Interiors, which is kind of our fit out arm. We're finding that the impact is much greater than that, and on some particular projects, it's upwards of 30%. So again, that's not indicative of industry as a whole. It might have been a particularly quote unquote bad project, or it might have had some issues with plasterboard, but certainly from our experience from walking around site and seeing how much does get thrown away, unfortunately, it's still one of our biggest challenges, and which is why I kind of haven't quantified it yet, but have this gut feel that the waste rates we're using might be underestimating the problem. Now, and I'll go into it in the next slide, that doesn't necessarily matter in the sense that what matters to me is the carbon footprint of what's happening on site, not so much of our measurements, but clearly, as we all know, and the reason we measure this stuff is that when stuff gets measured, it's more likely to get actioned, right? We're helping share the size of the issue and helping encourage, whether it's clients, companies, professional teams, to do something about it. The big one that I know Will asked me about was temporary works. And so that's, yeah, whether that's your props, your formwork, it's something that is not included in the minimum reporting requirements, that if you're following kind of the RICS guidance or I think it's EN 15978. So that definitely has a footprint, and would be captured in the sense of if there's anything that's used temporarily and then is thrown away during construction, because it would form part of our construction waste. But again, we don't necessarily have a sense of scale of just how much that could be increasing our overall site footprint. And I think Where that's important is particularly if we're making decisions and choosing between construction methods that might help us eliminate or minimize those, or maybe even choosing a material which means that we don't need to have formwork on site, or kind of some kind of temporary works. And then the last one I wanted to touch on, again, I don't necessarily think it's such a significant issue, but there isn't a great way at the moment in terms of when we're assessing whole life carbon of accounting for modern methods of construction or offsite manufacturing. So there's obviously a sense that this would help reduce our A5 impacts, because maybe we're on site for less time. Maybe we need less plant because we're kind of simply dragging and dropping, or maybe we have fewer deliveries. And so, yeah, we're using less fuel there. That's more the A4 impacts, but there isn't really a mechanism at the moment, or I haven't seen much that would help you capture the difference between a project that was built traditionally versus using some form of modern method of construction. So that's something that we're looking at, because that is an area that we're investing a lot of time and effort. You might have seen, I know there's been a few articles in iStruct about the jump factory and the stuff we're doing over at East Village. So I think it's about making sure that when we're making those decisions, we're making them with the full picture, because yeah, there's a chance that otherwise we're making decisions that look right early on, but when you're looking at the whole life carbon assessment, don't stack up anymore. And that's what we want to avoid. So another question I had and kind of wanted to touch on, and I'm conscious of time, Will, was, you know, how do we measure it? How do we tackle the performance gap? So Optimize is a system that we use at Mace, and we actually track every single one of the metrics I talked about. So we will measure exactly the amount of fuel we use on site, how much waste we produce and the nature of that waste, the water, the energy we use, and obviously we know where we're getting that energy. So I guess what I would say as a client is, you know, this is the level of detail that we want to be capturing on our projects so that we can start to get a much more accurate picture of what the actual A5 impacts are. So I've touched on that, but really just to wrap up, you know, what have we done to tackle our A5 emissions? As I said, from Mace, it's a huge part of our footprint. We've been running what we've kind of called clean tech trials, where we've been trialing prototypes and hybrid or fully electric machinery for some time. And what this has actually meant is that we are now looking at entirely diesel-free sites where we're only using electric machinery. And we've actually got a diesel generator ban on all our projects. We're working with our supply chain. So we're actually asking all our supply chain to have a net zero carbon strategy and targets in place, and working with them to help them along that journey. And I've mentioned that we're doing these as-built embodied carbon assessments. So using the optimized data we have to start to get a better picture of what the site impacts are for our projects. So what can you do? You know, I think thinking about reducing the amount of materials, I'm sure it's something that's been touched on already, at the design stage is going to have a massive impact, and actually creating a design that doesn't bring about more waste during construction. But really, I know that can be a bit challenging. So talk to the supply chain, bring the likes of us or, you know, specialized subcontractors in as early as you can. And make sure that you're measuring, you know, that your projects, whether you've done a design stage embodied carbon assessment, try to make sure that that's tracked, you know, encourage your client to get that assessment done all the way through, and then compare the results with what you predicted to what's actually happened on site, and share your findings with everyone. And so that's really just the main space is watch the space. We have a lot of data at Mace, and we now are very excited. We are going to be working with a student to try to analyze that and pull out some findings. So I'm hoping that very soon I'll be able to quantify some of the things I've touched on today. But I think that's me on time, so I'll leave it there, and then hopefully there'll be a bit of conversation and Q&A.
Thank you very much, Julia. Thank you for that. And yes, there will definitely be conversation. We've got a few questions coming through already. A reminder to everyone else, please do add them into the chat, and then we'll feed them back to Julia in about 15 minutes time. Thank you, Julia. So I'm now going to introduce Cameron. Cameron Archer-Jones, no relation to Julia Jones, I don't think. Cameron's a principal engineer at Covey, which is, pretty infamous for their bridge design. And Cameron's been doing quite a bit of, he's involved in a few different sort of strands of work around carbon that has cropped up over the last year. Probably the most recently is if you picked up the structural engineer when it landed on your doorstep, like yesterday, you will have seen Cameron's latest article in there. So really delighted to have him coming along and talking to us about carbon in bridges today. And I think there'll be a few parallels even for those of us working in buildings to what we're about to hear, but it should be a really interesting take on a slightly different part of the structural engineering world. Up to you, Cameron.
Thanks, Will. Thanks, Will. Let me know if the sound isn't coming through okay. I'm not sure about the word infamous. I'm sure a few people would challenge that, but no, thanks a lot for the introduction. And thanks very much for inviting me to present. The work that I'm going to present, I guess, or the story from Covey's point of view, is something that I started with a colleague, Dan Green, in the office here about a couple of years ago, when we were working on Mumbai Trans Harbour Link together and responsible for quite a lot of steel between the two of us. It was amazing, comparing savings from an additional sort of 5-10 minutes of refinement against sort of more tangible things like equivalent carbon in chicken and flights and things like what Paul was talking about. So again, echoing that sentiment of how important it is for the structural engineer to consider their carbon footprint. So I'm going to jump straight in with one of the first, I guess, bridge examples that we quantified in-house using a sort of spreadsheet-based tool to look at the carbon footprint of a bridge. This was part of a competition submission, which you've got the render over on the top right-hand side. From this, we had an initial quantities estimate, and we put it into the tool and were able to get a quick understanding of the breakdown of carbon in the bridge itself. But more importantly, in our approach and how we wanted to tackle this problem, we wanted to sort of package up the carbon in useful groups for the engineer. So, if we had limited amount of time, which you typically have in a tender or a competition, where do you focus your energy to save carbon? And this sort of way of looking at the problem gave us the scope to do that. So this one here, this example, when we first started, we just started with A1 to 3, and we used predominantly the database from the inventory of carbon and energy. So then we had one data point. We then reflected internally on how we could expand this up and sort of make a bit of an internal database to understand how we were performing on our jobs collectively, with the sort of main aim of helping us sort of get better over time. And with that, we needed more data points. That was pretty clear. So we collected the sort of quantity schedules that were readily available for a whole sort of set of bridges, some of which are on the screen at the moment, and put them through the same process, but then expanded it to include A4 and A5. The details I'll touch on the slide after next. But to summarize where the cards fell, this plot here gives a snapshot of that carbon data normalized by the functional area of the deck, which the functional area being what the sort of client pays for, the number of lanes, the clear width between handrails, that sort of thing. To give us a way to compare bridges that were twice as long or twice as wide with different sizes. And again, by tracking it through with the sort of subsystem and component from an engineering point of view, we could quickly track through what parts of the structure were governing its carbon footprint. And also by tagging it with useful information like the span length, the ground type, things like that, we could also get a feel for what other influences on the design side influence the carbon footprint. I'll touch on in a couple of slides sort of the headline results, but I think on the left-hand side, just to highlight, that's kilograms of carbon equivalent. So for a bridge, we're typically talking tons per meter squared. This is A1 to 5 life cycle emissions, as I say. And just one last point for anyone interested in sort of more data in this space, there's a good paper by David Collings published earlier this year. So what's different for a bridge when doing these sorts of calculations? I've put together a sort of list of dot points of things that we came across when we were doing these calculations. the sort of stepping through from the material manufacturer side, you've typically got higher strength concrete, which is not directly covered in the IC database or in the iStruct guidance, but you can do it with cement, proportion of cement in your concrete mix. And what may be deemed as more sort of traditional civil items in a bridge typically fall within our scope and get defined in our drawings and in our specifications. So the surfacing has to be included, which we've included. And earthworks, depending on if you're trying to compare a long bridge with a short bridge plus an embankment, shouldn't be ignored. If this is site one material, it's going to be very low in terms of its material manufacture. And then the materials for temporary works items, and a key example being if you're launching girders across whatever obstacle you're trying to cross with your bridge, that launching nose could easily have 20% mass of the girders itself that you're launching across. If that's then a single-use item, then that carbon is something that should be accounted for in some way or another. And again, sort of deferring to the iStruct guidance, there's guidance around how to allow for reuse of that temporary works. Transport, works the same way in terms of carbon factors, but just to note that the sites are typically less accessible and have longer transport distances. In terms of the A5 side, there's a lot of parallels with what Julia was talking about just then. The waste rates we use per the iStruct guide, but in terms of the construction related energy use on site, we instead go for the approach of using first principles, using a guide or in our case, we've used SPONS to get a guide of fuel use and sort of time for certain work operations on site, and then use government published conversion factors to convert fuel use into embodied carbon for site operations. And then lastly, just to note that there will be some additional guidance in the next issue of the iStruct how to calculate embodied carbon guide, but with the hope that certainly by the next revision after this year's, this will be more formalized. The other big difference for a bridge is in terms of the life cycle modules and the scope you consider. Certainly the minimum scope for a structural engineer is A1 to 5. That's the same as for a building or anything else that a structural engineer will be focused on, because that's what we have most control over. But in the context of transport infrastructure, the sort of broader network that you're fitting into has an extra sort of carbon influence overall if you're doing a whole life cycle assessment. And that's the carbon emissions associated with the users that use the infrastructure. So the photo top right, all the traffic that crosses a bridge, that over the lifetime of a bridge will, in some cases for a highway bridge, dwarf the actual carbon, the capital carbon itself. So depending on the stage of the project, in a bridge context, the bridge engineer will get involved quite early. And if you're at the point of considering route options, it may well be, at least from a qualitative point of view, if you can push for a shorter route overall, but has a longer bridge and therefore a higher capital carbon, considering that sort of users associated emissions can be important. But again, to caveat, in terms of the structural engineering side, that needs to be sort of carefully weighted into, and should it involve the support of a traffic engineer or transport planner. Also, just one last point on this item, if your bridge encourages mode shifts away from a less carbon intensive mode of transport, that's also something that can be considered, at least from a qualitative point of view. So from the data that we compiled, as Will mentioned, Dan and I popped all this down into a paper which is published in this month's Structural Engineer, and we had a go with the data that we had to try and propose a rating system so that any engineer looking at a bridge that didn't quite have access to data like what we were able to get our hands on, they can get an understanding of how they're performing with just their current project without having that background data. So we were typically finding ranges of capital carbon between 1 to 3 tons per meter squared of deck area. It was typically governed by the material manufacturer, but as I say, in comparing options, if you're looking at a shorter bridge with more embankment, the construction related emissions for hauling lots of earthworks around your site can quickly add up to something quite significant. Overall, from the data, there was a clear link with span length, but not always the case. So one of our smallest bridges also had the same sort of carbon intensity per meter squared as to one of our largest bridges. But excluding the sort of very short spans, there was a clear dependency on span length and carbon. Then the load type, so if it's road, highway, or pedestrian, will influence it, and the sort of principal superstructure material we found influenced in the data we had, where we were finding that a concrete superstructure would typically perform better than a steel superstructure. But to caveat that the limitation on the data that we had, we couldn't completely separate the sort of variables of span versus that principal superstructure material as well. So when looking at a bridge, how can we reduce our carbon? A lot of these sort of the options available to the bridge engineer overlap with buildings. But to highlight some of the things I think that are more exclusive in the bridge point of view is that a lot of our work is focused on existing assets, bridges that were built in the past that now have more onerous traffic loads on them. And typically, a lot of that effort is resolved around finding capacity where there wasn't designed for. So, you know, following load paths and sort of squeezing everything out of capacity side for an assessment is not that uncommon in a bridge point of view. But one extra step is on the load side. So something that can be done is what I've called up a bridge specific asset live load, where you use weigh in motion data to come up with a bridge specific live load and therefore reduce your applied side. For a new bridge, I've pulled out some of the sort of parameters that you'll think about early on when developing a concept around the functional width, sort of again linked to the overall size and thereby reducing the carbon footprint of the bridge. Constraints around support location. So with that clear dependency on span and carbon, if you have a constraint that prevents you from putting a support in various locations, it may just encourage you to sort of go back and really challenge that and see if you can reduce span. Then sort of any special loading, so heavy vehicles, ship impact, those sorts of things can, with a sort of carbon hat on, attract more attention. Certainly in the case of, you know, ship impact, where it can easily just be sort of covered by a code without delving into data. And if ship impact's governing your substructure, which is not uncommon, then, you know, it can be an easy argument to make to a client to ask for a bit more time to look in that in more detail. Then in terms of the sort of design efficiently, assessing efficiently, a lot of these overlap again, and I won't sort of step through all of them. I think the one to mention on the existing bridge side is to consider, though, if you're proposing a strengthening regime with options where one requires a possession of the road exclusively for that works and then leads to traffic detours, to think about that in the context with perhaps maybe an option with slightly more capital carbon, but a reduction to the sort of impact to traffic and the extra emissions from that. And then lastly, material specifications, which has been very well covered in the previous 3 talks. So then just to sort of wrap up, I think to bring it all back together and touch on some of the shared challenges, I think that completely are not exclusive in a bridge context, is the focus on extending the life of existing assets. That's certainly very common. The forums like this, where we can share results, share sort of some of the limitations on doing carbon calculations, carbon factors, and share sort of outcomes of those examples is obviously hugely important. And then also the materials challenge that we face. Concrete and steel, in terms of materials themselves, are so well embedded in our industry, which compared to others is quite traditional. But through the sort of collective action, we can help drive that change. I think not underestimate how important each and every time in a project, if we ask for something a bit better in a carbon point of view, you know, you can sort of turn the ship and and hold back the tide a bit. So I will end on that note.
Thank you very much, Cameron. And I think, I mean, I'd also add, I think there was one thing missing from that final slide, which is, you know, you touched on the need as a bridge designer to think, you know, quite holistically in terms of user carbon as well. And I think there's a lot of that resonates with building designers as, you know, not always staying in your own little embodied carbon world, but just, you know, make sure you sort of peer over the parapet every now and then and just ask what decisions you're making and whether they affect any of the impacts of the wider design team.
I did try and think of the most direct parallel to the users in a building context. The only thing I could think of is if you had a gym that then made all the humans in it breathe more intensely. Is that carbon? Is that carbon captured? That's the only direct example I could think of. But certainly that holistic sort of view is important at that early stage.
Yeah, no, absolutely, and yeah, like you said, the earlier the better. Thank you both, Cameron and Julia, for that. So we've got about 10-12 minutes of Q&A time. Obviously we've had a few through already, but do keep putting them in the chat if you anything else comes to mind. We'll start with Julia. And actually, there's an interesting question which kind of goes a bit back also to what Paul was saying, but Paul might have even been the one to ask. No, Paul was the one to ask it. Well, that would be why. So have you got any comments, Julia, on the sort of around the carbon cost of changing materials once you reach site? So obviously the difference between specified concrete and what appears on site can be quite big, and how do you control that as a main contractor?
Yeah, I mean, I think it's a really good point, and it's absolutely something that even when we're the main contractor, we struggle with. So we worked on UCL New Student Centre, and which was going for BREEAM Excellent, ended up uplifting that on site to get to BREEAM Outstanding. And I think that was a massive learning curve in terms of just how closely you need to monitor the concrete works if you want to stay on track. So we were targeting very high cement replacement content and GGBS content on those, and so it literally had to be like we had a tracker that was almost like alive every day. We had to keep track of it and update, and you know, someone would phone up and say, oh, this has happened on site, we've had to adjust the mix. So we definitely learned that it's not a simple thing, but I guess on the flip side of it, what it proved is that it can be done. So I think that's where you use your procurement and your contractual mechanisms to hold people accountable. Ultimately, hence the answers in the name, we're called contractors. So if you put it in our contract, chances are we're going to stick to it, because it's going to cost us to not do so. So I think that, you know, if you really want to be robust, that could be a way of doing it, of actually saying, well, I know there's carbon impact of making that change, which, let's say I'm targeting net zero carbon and therefore I'm going to offset. Well, actually, contractor, you need to make up the difference in the offsets if you decide that you need to change the concrete mix.
Yeah, no, very, very wise. And I mean, Cameron, like as a bridge designer, you have to think a lot more about how things are built, I'd argue, than most building designers. I mean, it's a really core part of your job is how on earth are we going to get this thing to exist in place from the spans you deal with. Does that, I mean, do you see that as presenting any big opportunities for you in terms of the sorts of things that Julia is talking about, and that closer liaison with the contractor team to help you track what actually gets built?
I think definitely, because there are, although we put a lot of effort into, you know, understanding the construction sequence, particularly because there will be generally cases where it will govern the design or parts of the design, and then the locked-in dead load once it's finished being built. But I think the close relationship with a contractor is very good, because there'll be aspects that you may not fully appreciate without that initial feedback. So if you're proposing a method and you think it's actually saving a bit of temporary works, that early feedback is invaluable, because then you can say, well, you know, although this requires a trestle rather than a form traveler, we can reuse 95% of the material in the trestle, but the form traveler is more bespoke and you've got more wasted material, as a sort of hypothetical example. So I definitely echo that sentiment.
Yeah, no, great. We've had an interesting question. I mean, this is sort of site emissions based thing, Julia, around, so you mentioned, you know, how it makes you're switching over, you're moving away from diesel generators. In fact, I think you might have said you banned them completely. But obviously, you know, diesel powered electricity is, yeah, it's cheap, isn't it? Right, it's super cheap. I remember going to do a thing in the rainforest once, and they just had a diesel generator, and they were able to refer to themselves as off-grid and eco-friendly. And then, of course, you could hear the generator running, kind of spoils it a bit. Do you have any sort of thoughts and recommendations about what needs to happen in order for sites around the world to be able to move away from such cheap sources of power? And we want cleaner ways of building things.
Yeah, absolutely. I mean, it's a really good point, and I guess there's a couple of layers to that. My first one would be there's still a whole load of sites in the UK that that use, or in in the US or Australia, that use diesel generators, when actually it's definitely possible to either get yourself sorted so you get temporary supply in place sooner, and you actually don't need a generator for temporary power, or you could afford to use a either a hybrid or an entirely kind of electric generator that might come from like a solar powered, for example, or even we are starting to look at like things like hydrogen fuel cells and the like. So I guess my first point is we're still not doing it in the countries where that's not an issue. So like, let's tackle that. But it's fair. I think the great thing with things like solar panel, and like there are renewable energy options that are very like decentralized. So if you can apply those, then it'd be about encouraging it to do that. But it might be the case that there are some instances where that's your only option, but it's about saying, has the project looked at every single option before you've done that? Just the final point on cost. What we have found, and again, I appreciate this might be location specific, what we have found is that whilst the electric or hybrid systems might have slightly higher rental costs, you're then saving on your fuel. And as we have issues with fuel, whether it's supply or cost increases, etc., we actually find that they often become cost neutral because you haven't got that fuel use. Plus, you've got other benefits. So as a client, I would say you then have your reduced risk of spills and pollution, improved local air quality. They're quieter, so it's less disruptive to neighbors. So there's like all these co-benefits that maybe aren't quantified in pure cost terms, but really should be taken into account when making that decision.
Yeah, my brother-in-law actually went to a site recently where he said that everything was electrified, and he said it was amazing to be able to sit in a site cabin that was running off wasn't connected to the mains, but being able to hear people speak without having to shout at them was quite a novelty. So yeah, definitely unquantifiable, but definitely not immeasurable. Yeah, for sure. In terms of, moving towards electrification of things, Cameron, you mentioned, transportation and the need to account for alignment of bridges and things like that. How do you think that's going to change in the future as more and more cars on the road are electric cars, and so arguably the emissions due to driving places will go down? Do you think that's going to change how you think about this topic, or is it just too far away to be a concern right now?
I think for a sort of a mega project where it may not be finished or built for 20-30 years, it can't be ignored. I think I'm certainly not well informed enough to comment on how it's going to change, but obviously the targets that are set out to electrify more cars and trucks, you would expect to lead to a reduction in that sort of user emission. I think the context where we can sort of focus on it is, again, in assessment of a bridge. If you need to shut it next month and you already know the daily traffic count, then that's where you can start to think about it and probably more defendably comment on the influence of it. But yeah, long term, I think that's where we need sort of transport planning input and a sort of wider picture input.
Yeah, much bigger picture input for sure. We had a really interesting question. This is for you, Julia. This is around offsite manufacture and modern methods of construction, as people call them, which is, don't know what's so modern about it. The question was, should the emissions of offsite manufactured products be just addressed with EPDs for those products, rather than trying to come up with sort of theoretical estimates that we can apply to our design? And I think the really important point here that's made in the question is that, of course, if you're going to go down the offsite route, you really do need to have a contractor on board early anyway. So couldn't you do, you know, more in-depth study of this kind of stuff? What do you think?
Yeah, I agree. I mean, that's also the challenge, what I'm saying, like with the models, because the EPDs, most EPDs are fairly, are looking at things at the component level. You might have EPDs for like a whole window system, but for a wall, you tend to, or a floor system, you know, you tend to be going down to the individual materials. So then if you're trying to use that, but actually it's been put together on a site, where are you accounting for the waste, energy, and water used in that factory, or in that assembly center? So I think you're right. The more we can have like product specific, and the product might be a building, or it might be parts of a building system. If you can have an EPD, it's going to be much more accurate. And I think it's one, I don't know if I know I've talked about with colleagues before around actually making sure that we aren't increasing carbon by moving offsite, because you might have reduced your A5 impacts, but if you've ended up, I don't know, having to put more steel reinforcement in something, or doubling up on layers of plasterboard to help, because I don't know, you need enough rigidity to get it to site, you might inadvertently be actually driving the embodied carbon up. So completely agree, if you have a product specific EPD, that's the right way to go. The challenge is, at the moment, it's going to be really hard to find. This isn't a plug, but where we are doing these things and we're looking at things with our group technical services team, they are actually developing, we're actually measuring the carbon of our products. So so that we know that when we're using it on projects.
No, that's really interesting. And again, you know, goes back to this sort of bigger picture, trying to keep the bigger picture, not just trying to concentrate on your own piece of the pie, for sure. Look, thank you both. Yeah, I'm going to move on if it's okay, because I've got a nasty habit of being late on all these things, so nice to be on time for a change. So thank you again. You know, lots of parallels there between sites and bridges, and lots that we can learn. And hopefully you'll both stick with us for the final few presentations of this afternoon as well.